Hi guys, Mr. T again, and here we are. We're gonna, well, let's move this over here out of the way. We're still talking about probability, and this is the second one we're doing. It's a little introduction to probability anyway. We did conditional probability with two-way tables beforehand, and you see all the different pictures. We got, dice and flipping coins and picking out marbles and cards, all the classic things that deal with probability. Um, Today in this particular video, we're going to look at the idea between independent and dependent events. Okay, so what's the probability depends on what happened previously sometimes. So that's kind of what we're going to be looking at here. And so we're going to be looking at independent and dependent events and how that affects the probability of a situation. Okay, let's look at a couple scenarios here dealing with independent and dependent. So we got a bag with 3 chips in it, okay? No, and you're going to draw 2 chips out of it, okay? So that's the scenario that we're going to do. Now, in experiment 1, okay, in the first experiment here, we're going to draw 1 chip and then put it back. Okay, so that's a kind of an important thing there, okay? This idea. We're going to, not only are we going to draw, we're going to put it back. Okay, that's a very important thing. Okay, that's called with replacement. And then we're going to draw another chip. Okay, so we're going to reach in, all right, pull out a chip. Say, oh, that's nice. Write it down, put the chip back in, shake it up, pick out another chip. So that's what's going to happen. Okay. Well, because we put the chip back, the second draw has no effect, does not affect draw 1. So they don't affect each other. So these two are called independent events. Okay. They're independent, where the second thing is not affected by what happened previously. Okay. And that's because we put it back. That's with replacement, is how they say that. So how would you figure that out? So when you have independent events, you do the probability of the first thing, okay, times the probability of the second thing. So in probability, when you say the probability of A and B, that's saying multiplication. And I tell you something, whenever you're doing probability, just assume it's going to be multiplication. There is an occasion where there could be some addition, but that's where you're going to get an or in those kind of situations. But just assume you're going to be multiplying your fractions, okay? So what would that look like? Well, we slide down here. So what's the probability of red and red? So what's the probability of red? 2 out of 3, right? We're going to put that back in. And now what's the chances on the second one? 2 out of 3. So 2 times 2 is 4. 3 times 3 is 9. Always reduce our fractions, but 4 out of 9, that's all you can reduce anyway. So that's scenario 1. That's where we put it back in. So that's independent, right? Well, in scenario number 2, experiment number 2, we're going to draw 1 trip, then what? Draw another one without replacing the first one. So we're going to reach in, draw 1, put it to the side, then reach in again and draw another one. Well, the second draw is affected by the first draw, okay? So 2 events are dependent when the outcome of the second is affected by the outcome of the first, okay? And so the way this is set up is if A and B are dependent, you're going to say probability of A, then B, okay? So the probability of A times B after A has already happened, okay? So how does that look like down here? So what's the problem? So we got 3 chips in there. We're going to reach in. What's the probability of getting in a red? And then red again. So, well, probability of getting a red, 2 out of 3. Okay. Now we're going to do what with that? Put that to the side. Okay. So what's the probability of getting another red? Well, I know. So the only way I can get 2 reds is if I got a red the first time, right? So I know the first time was a red. So I got 1 less red. What else do I have? I got 1 less chip in the bag too, right? So I have 1 out of 2 chips, period, left in the bag. So now that's a 1 out of 2. Okay, so this guy is probably of red after they got a red the first time. So 2 times 1 is 2, 3 times 2 is 6, 2 6 is 1/3. So that's two different scenarios. That's with replacement and without replacement. So we got several different little scenarios here, just kind of to just briefly hit the tops of this idea. There's plenty more that can do. It's a very big, broad idea. Well, this is kind of an introduction. All right, so we got a bag here that has 3 green markers. I'll tell you what, let's make it even better. Let's, if it's green markers, why not we highlight 3 green markers, okay? And then let's do highlight 3 blue markers, and then we'll do 2 yellow markers. All right, we even color code this thing. How about that? Okay, it says you're going to randomly choose one marker and then what? Replace it. Oh, that's super big time important. Then replace it. Then you're going to choose a second one. All right. So you're going to probability of getting a green and a yellow. So what's the chances of getting a green? Well, that's 3 out of 3, 6, 7, 8. So that's 3 out of 8. All right, what's the probability of getting a yellow? Well, since you put the marker back in to our bag, there's the same as there was before. So there's still 8 markers, okay? And now the chances of yellow is 2. All right, so we're going to multiply these two guys, right? So 2 times 3, that's 6. 8 times 8 is 64. You know, I probably could have done some cross multiplying and things like that to reduce this out. Okay, so, but you know, I got this fancy calculator because, so watch this. So it's 6 divided by 64. There's the decimal version, but check this out. Math, frac, enter, and bam, there's the reduced fraction. So, you know, why you get upset about fractions? There's no big deal if you got these nice calculators hanging around. Now, not that you should have to use it, but you got it and you need it, use it. So 3 over 32 is what that would reduce down to, because we always reduce over our fractions, okay? It's not saying anything about rounding to decimals, so I'm going to leave it as a fraction. So 3 out of 32 is your chances of getting a green and a yellow when you replace it. So again, so what's this? Probability of green is what? 3 out of 8. Blue is going to be 3 out of 8, so it's going to be 3 eighths times 3 eighths, blah, blah, blah. How about yellow? Okay, so what about them both being yellow? So, well, it's going to be 2 out of 8 for our first round, right? 2 out of 8. But since we pulled a yellow the first time, is that going to change something? No, it's not going to change it at all because we put it back, didn't we? So it's still going to be 2 out of 8 the second time. So 2 eighths times 2 eighths, and then you reduce your fraction. Okay. All right. Now, what about this guy? Oh, my. Socks. Oh, everybody loves socks when you're talking about probability. Everybody loves socks. So we got 3 green socks. We got 4 blue socks. And I'm going to do yellow. Yellow and black go together real well, don't they? I hope so. So, all right. So how many socks? 3 plus 4, it's 7, plus 2 more is 8, 9. So there's 9 total socks in our drawer. Okay. Now those pairs of socks or individual socks, I don't know. We're not going to worry about that. Okay. So, all right. So what, but now, ooh, watch this. What's this say? We are not going to replace. Okay. So we're going to pick one sock out. All right. At a time. Okay. And then we're not going to replace it. Oh, so, that's going to be a big deal. So let's do a couple of these real quick here. So what's the probability of getting a blue? Well, I'm thinking it's going to be 4 out of how many? We said that was 7, 8, 9, right? And then we're not going to replace it. So we're going to reach in, get us a nice blue sock, put it to the side. So now how many socks do we have? We only have 8 socks left, right? So we're going to have to change the denominator on the second fraction. Okay. Now, again, it's multiplying unless you see something that, like usually an or sign that gives you an addition. It's going to be multiplying. Um, okay, so probably getting a blue, then a black. Okay. So, did we pull out any black socks the first round? No, so that's not going to affect it. We still got 2 black socks running around. We just only got 8 total. So it's going to be 2 out of 8 here. Okay, and again, 2 times 4, 8, 9 times 8, 72, and you need to finish that off. Okay, green. Okay, so that's going to be what? 3 out of 9, and then what? 4 out of 8. Okay, so you get the idea there. So when you don't replace, that means these numbers on the second ones are going to change. Okay. So they didn't do this in this scenario, but what about the same thing they did with this, like these 2 yellows? What if it was 2 blacks? So I think that's an important question they should have asked. So what's the probability of getting a black sock, okay, then another black sock? Okay. Well, what's that going to do for us? Well, the probability of getting a black sock is what? 2 out of 9. Okay. Now, when I take that sock out and leave it out, I'm only going to have 8 left. But what else is going to happen? Oh, I'm only going to have 1 black sock left. So it's not going to be 2 again. It's going to be a 1 this time. So because I stayed with the same color, it affected the numerator and the denominator. So you got to watch out for that scenario. Okay. We're going to switch gears here. Now, this one is just talking about, is it dependent or independent? So this is scenario independent or dependent. Okay, let's pull this up just a little bit. Well, flipping a coin will always be independent. Okay, no matter how many times you do it, it's independent every time. So the next one here is selecting a can of corn and a container of juice at a supermarket. Well, if I go up to the shelf and pick up a can of corn, does the shelf, and I put it in my basket, now the shelf has what? 1 less can of corn. So the probability of getting another can of corn is going to be different than it was before. So that's without replacement. So that's a dependent. Now, but is that what they're saying here? No, they said get a can of corn and a container of juice. Well, since I'm not getting 2 cans of corn, that second can doesn't really matter. So we're going to go get a can of corn and then a container of juice. Well, whether or not I get corn first doesn't change the thing about juice. Okay, so if I got 2 things of corn, that would be dependent. But since I got corn and then juice, they have nothing to do with each other, completely different aisles, so they would be independent. All right, choosing a hammer and then a paint color. Would they now does one change the other? Then picking a board from a pile, nailing it to a fence, then picking another board from the pile. So if I got a bunch of boards here, and is when I pick up the board, do I put it back? No, I'm nailing it. So that's without replacement. And we said what that means earlier. Okay. Now, whoops, get too far too fast there. Okay. So flipping over to the back side of the page that we're working with, it says, here's a scenario. Here we got a shelf that holds 3 novels, 2 biographies, and 1 history book. And 2 students are going to in turn choose a book at random. What is the probability that the students choose each of the following? So one student goes up there to the shelf, grabs a book, comes back to their seat. They don't put it back. Okay. And then the next student goes up to the shelf and grabs a book and goes back to their seat. So that's what we're talking about. So what's the probability that both of the students are going to get novels? Well, the probability of getting a novel is going to be 3 out of 6, also known as 1/2, but that's okay. Then the next person goes up. How many novels are left? 2. How many books are left? 5. And so then we multiply that. Okay. And then the same thing goes with the biographies. Okay. So since you're getting biographies, both the numerator and denominator will be affected on the second one. Okay. But now number 3 here is a history and then a novel. Okay. So since we're changing history and novel, that's not going to mess with our numerator much because history is going to have one book. And then and it doesn't really matter if you get a history or a biology book to a novel, right? We're still going to have 3 novels. So you got 1 history book and then 3 novels. So that's no big deal. But the denominator will change, right? Because you're still going to have 1 less total book. All right. And then we got both history books. Okay. Um, I wonder. I bet you can figure out what happens there, don't you? Since we only have 1 and we're trying to pick 2. All right. So then Megan flipping a penny, giving the number of times. What is the probability, the results of the as follows? Okay. So Meg flipped a penny the given number of times. So that means she flipped it twice and she got 2 heads. Okay. So that means so each one of those, what's the chances of getting heads the first time? 1/2. What's the chance of getting heads the second time? 1/2. And then you multiply those guys together because flipping a coin will always be independent. So that's how that will work for each one of those. Since they're independent, it really doesn't matter what happened before. Okay. So you can walk through that. Say, all right, a couple more little things going on here. So we continue to look at this same idea of independent versus dependent and how that can affect our probability. Okay. We got 2 puppies are chosen at random from a box at the mall. Okay. What is the probability of these outcomes? Well, this seems strange to some people. Well, back in the day, you know, where malls were even more popular than they even are today, what would happen was almost all malls had a pet store in them. Okay. Not like we have like PetSmart, things like that, that are in a outdoor strip mall kind of thing that was inside. And then, as you be going down there shopping for whatever you're shopping for, you see these cute little puppies in the windows and things like that. And, they make a big business on that. So this is kind of what they're talking about here. And in this box that they got hanging out there, we got 5 black retrievers, 3 brown hounds, and 4 black setters. That's what's in our boxes for free puppies for adoption. Oh, goodness, it's probably not a store. I don't know how they don't do things for free. But okay. So what's the chances that you go up here to pick 2 puppies and that they're both are black? Okay. Well, there's 5 black retrievers and 4 black setters. So how many black puppies are there? 9. So there are 9 puppies that are black. And there are how many total puppies? 9 plus 3 is 12. Okay. Now we could reduce that, but I'm not going to worry about it right now. Okay. And so now what's going to happen? How many puppies are in the box? 11 puppies are in the box now. How many of them are black? Well, you just took one out. So that means you got 8. So then you would multiply that out, reduce your fraction, of course. Okay. And so that's kind of what's happening here with this kind of scenario here. Now, this one say they're both brown. Okay. This is a retriever, then a setter. Okay. So how many retrievers are there? There are 5 retrievers. So that's 5 out of 12. And then the next time would be what? 4 setters. And so that'd be 4 out of 11 because we're still going to have one less puppy. True. Okay. So, all right, last thing here. We got 2 more little questions here. And which of these are independent or dependent? And explain. Okay. Well, we got a guest at a party takes a sandwich from a tray. A second guest then takes the sandwich. Just going to ask you something. Did the first guest put his sandwich back? I surely hope not. So I guess that would be without replacement. And we know what that all means. So you should finish that off. Now, Sam flips a coin and gets heads. He flips it again and gets tails. Well, we just talked about what does that mean? Flipping a coin. What's that always mean? So I just got finished saying something about that as well. So I'll leave those two without much help for you, or to do that because you should be able to manage those by now. And I think that's about it. So we've been talking about independent situations as opposed to dependent. And one of the big, most common things when you're picking something, you know, and you put it back, that doesn't change anything. So that's being independent. If you pick something out and then you put it to the side for any reason, that's going to change your denominator at the very least for the next round because you're going to have less things there. That's without replacement. Okay. As always, hope that is helpful and y'all have a great day. Oh, and Merry Christmas. At least that's when it's getting close anyway. Bye.